Hi students, I am Dr. Badrinath. In this video, we will see the UV spectroscopy instrumentation part. Okay, that also I make a two parts in the instrumentation because instrumentation is very important. I am giving all the basics. Okay, straight away it goes to your mind. Okay, two parts I am making. Part one we will see. Right? Yeah, here you can see the nice, very nice and very elegant instrument. This is called a UV spectroscopy. UV, see here, name carefully, UV visible spectroscopy, spectrophotometer. It is using for the both UV analysis and also visible analysis. If your solution is color, you go for colorimetry. That is visible. It comes in the range of visible. If your solution is colorless, you go for analysis of the UV spectroscopy. This instrument is a combination of both UV spectroscopy as well as the colorimetry. Both are combined here. Keep in your mind. That's why we are calling it as a UV visible spectrophotometer. Okay, and the model is UV1900. This is the model number. And who is the manufacturer? Shimadzu is the famous manufacturer. Number of companies are available, but keep in your mind, Shimadzu is the topmost Japanese company, and it is very successful, more precise, more accurate, unbiased results will be get in the Shimadzu company. See here, this instrument color black and white color available. And in the Japan, doll festival is famous. It looks like a Japan doll. Japan doll is world famous. World famous. So Shimadzu is a basically company from the Japan. Uh, and here you can see the small instrument. This instrument is only colorimetry, colorimeter. Okay, it is used only for the visible spectra only. Okay, that is 400 to 800, that is nanometers, that we know very well, visible range. So keep in your mind, now all manufacturers are manufacturing UV visible spectroscopy, both. That's why we have to learn it side by side only. Okay, yeah. This diagram here, what you are shown, this diagram you can write in the exam. Don't draw this diagram in the examination, regular examination. If you write this diagram, it becomes like a radio, FM radio, or it comes like a TV, like that. Okay, don't try. This is for a photograph, not a figure or not a diagram. Photograph. You don't draw this in the examination. Keep in your mind, right? And which diagram we have to write in the exam? This is okay. So inside the UV visible spectrophotometer, it consists of these things. These things are happen. These things are the important parts. But outside, if you see, no, you cannot see any part. You cannot see any part. Outside, it looks like a very simple box, whereas inside, it consists of these parts. First of all, see here, it is a light source, very important one, very light source, because we are using a for visible range. Visible range 400 to 800 nanometer. We are using a tungsten filament lamp. Tungsten. I already given the code. Visible rays. Tungsten is a lamp. Tungsten filament lamp. Tung means visible. Tung. Both are nearby. Like that. I already gave the code. And for UV rays, we are using a light source H2D2, hydrogen lamp, deuterium lamp. These are the two lamps. Either H2 you can use or you can use a D2. Okay, it gives the UV rays. These type of bulbs gives the UV rays. Tungsten filament lamp gives the visible range. Keep in your mind. I already told natural source. Who is a natural source? This is our God, sun. Sun is a natural source of visible rays. Sun is the natural source of UV rays. Sun is the natural source of IR, infrared rays. But we are not keeping the sun inside our instrument. Okay, he is a natural source. Here we are using artificial source which we prepared in our regular labs. We will prepare these bulbs and we are going to be keep in your mind. So this is one of the important part. And here I have shown compared the side by side to avoid the confusion for the students. Visible range, light source is tungsten. UV means HD max. I will explain you what is a HD max. Keep in your mind. Next is prism, monochromator. This name is called as a monochromator or prism or grating or filter. Filter. All these names are same only. Keep in mind. It is a very important part. Monochromator. It widely disperse. See here, one ray is coming here. See here, three rays combined together, and it is coming here like. Here, this prism will disperse one, two, three, like that it disperse. For example, in UV range, if you are taking, UV range 10 to 200, okay, 200 to again 400, okay, that is in, I already discussed it in my first video. 400 to 800 is a visible range, okay, 400 to 800 visible range. Keep in your mind. So all the rays, it comes in one light that is called as a polychromatic. It is converted into monochromatic. Rays will be dispersed. So here you will get a 10 and up to 400 here widely dispersed. That is the main job of the prism. Each ray, each radiation, each wavelength will be separated. Just like a white light, when you pass through a prism, you will get a dispersion. VIBGR you will get. In the same fashion, you will get here. Okay, that's why it is called a monochromator. Mono, it means a single. This is a source is a polychromatic. Poly means many. Okay, now slit. See here, this is slit. Allows only one radiation, what we want, where we want the lambda max slit. So once you start the switch on the instrument, what happen, and you fix the reading, suppose say 250, 250 is within the range of UV. So automatically what happen, H2 bulb or D2 bulb start glowing, not the tungsten, because both lamps will be there inside the instrument. UV source is there, visible source is there. Depending upon whether the what wavelength you have pressed, based on that, that bulb automatically it glows. And prism also, there is a two prisms are there. Here see monochromator, glass prism, monochromator, invisible, quartz prism or gratings or filters in the UV. Automatically, this glass prism will go and the quartz prism, just it comes and it fixed there. Okay, when you switch on the UV range lambda max in the instrument, automatically it sets inside. Okay, and slit, which lambda max you have fixed, only that ray will be allowed. Remaining all are blocked by the slit. Slit, that is very important. And so only one ray will come outside the slit, what you have fixed in the instrument, that fall on the sample. That fall on the sample. Sample will absorb the sum of the radiation. That radiation is called as I0, initial or incident radiation. Some incident radiation absorbed by the sample. Remaining things, remaining light, this is called as I. This I, see here, dotted line, how many dots are here? Some dotted lines are absorbed by the sample. So remaining dots are came here. That is called a I. This I falls on the detector. This is the important one, detector. This detector here, I will explain you in my videos. Don't get confusion. This detects how much light is coming. So how much light is coming, if you detect how much absorbed by the sample, that you can calculate. Okay, and it directly it displays on the recorder. It records and it shows. Okay, display you can see. So important parts are light source, tungsten, HD max, monochromator, glass prism, quartz prism, grating or filter. Next is sample holder, is a glass or plastic. Here quartz, keep in your mind. And detectors, PVC, PCC, PT, PM, PGP. That I will explain you in each slides, but you keep in your mind, first of all, in this video, we will see the light source and monochromator. That only two topics we will complete in this video. Next video, sample holder and detectors, I will make the video. Okay, first, see here, this is the same diagram only. Here you can see deuterium lamp, D lamp. I already told no D lamp for UV rays. This is the tungsten lamp. Okay, and when you switch on the visible range or when you press visible range lambda max, tungsten filament will glow. Okay, and UV range, if you fix, automatically deuterium lamp will start glowing of it. Okay, like that. This diagram is I will like we will see, take a screenshot if you want. In the examination you have to write this diagram. Okay, this is a single beam, this is a double beam. I will explain you what is single beam, what is double beam also. Yeah, this is a visible source tungsten lamp, tungsten lamp for visible range. See here, this is a glass bulb, gas, inside gas is filled. See here, this is the important part, tungsten filament. You can see this filament directly in your childhood. These are the bulbs we are using in your childhood. Okay, but nowadays all are LED bulbs only. In olden days, tungsten filament. Major tungsten is a filament. Like you will get a 200 watts, 40 watts, 60 watts, like that. You will get a number of things. Okay, tungsten filament lamp. Okay, it supports the wires. This and all not required. This part is very important. Tungsten filament, glass bulb, gas filling. Now this is a source of UV rays. I have already told no. So here four sources are there: hydrogen discharge lamp, deuterium lamp, mercury lamp, xenon lamp, xenon discharge lamp. Four lamps are there: hydrogen, deuterium, mercury, xenon discharge. All are source of the UV rays. Okay, how to make this? Remember this. I kept the one code here. See here. This is called a code is called a HD max. HD means HD TV, high definition TV, HD diagram, high definition, high resolution diagrams, HD, high definition. Maximum we can see maximum. So generally we are using maximum TVs in our houses or HD TVs only. H stands for hydrogen, D stands for deuterium, M stands for mercury, X stands for xenon. Simple trick you can remember. Now we will see hydrogen discharge lamp. First one, it is a very stable. This is a real picture of the source of UV. This directly you cannot see. You want to break the instrument, UV spectrophotometer, open it, then you can see, find whether which type of lamp it is and all. Okay, this if you see the directly, this is the diagram, hydrogen. Very stable. First, hydrogen, helium, lithium, beryllium, boron, that periodic table. Hydrogen, very stable, robust, widely used. Range is 120 to 350 nanometer. You can use up to that. It provides the wavelength of this range. Hydrogen gas is under pressure, high pressure gas. You have to fill in a bulb and you supply with electric connection, so that automatically it gives the source of UV rays. H2 is the symbol. Keep in your symbols, keep in your mind. Visualize, for easy visualization I made. Next is deuterium lamp, also called as a D2 lamp. This is also most widely used and expensive, very important. A, B, C, D, E. D, E both side by side. Deuterium lamp, expensive. Deuterium gas we are using. That's why it is called a deuterium lamp. See here, deuterium, this lamp. We are going to fill the gas inside deuterium gas. Okay. And xenon discharge lamp. Intensity is greater than the hydrogen lamp and deuterium lamp. X2 you can This X you can use it as a technique, simple tip. It is a multiplication of xenon. Name itself indicates xenon. It also stands for multiplication. That is greater intensity than the H2 and D2. Like that you can remember in your mind easily. Xenon gas. Okay, into 2. Here you can see the real picture of the xenon lamp. This also acts like a UV source. And last one, mercury arc. Mercury means, this is the symbol of mercury. We are using for various manometers, okay, plethysmographs, all this we are using, no? Padarasam. In Telugu, it is a padarasam. It looks like very white, not widely used because it is dangerous. Hg is a very dangerous. In thermometers also we are using. Mercury vapor we are using. Mercury vapor will be there. Here we are not using mercury liquid. Mercury liquid is used in the thermometers. Mercury gas using in the bulbs, mercury bulbs. These mercury bulbs is looks like a white. Okay, here I will show you. Mercury versus sodium light. These are the street lights. In the street lights also same. Uh, See here, white bulbs you saw. This is called as a mercury. In olden days, nowadays it is filled by LED only. Wherever you go, you can see the LED. In olden days, in your childhood, you just keep watching the street lights. Very big bulb will be there here, and it gives the white light. It is a source of UV, dangerous for skin. Whereas a sodium lamp, gold color lights also you are able to see on the roads. That is a sodium lamp. Okay, this sodium lamp we are using in polarography. That is polarimeter, plane polarized right. It is rotating towards the right side or left side. That and all. It is a separate chromatography. Okay, and now we will see the monochromator. First light source completed. Second, we will see monochromators. Filters, monochromators are also called as a same. See here, light gives the radiation from 400 to 800 nanometer. Okay, this is called as a polychromatic light, which is of several wavelengths will be there inside. Hence, a filter or monochromator is used to convert the polychromatic light into monochromatic light. There is a two types of filters and there is a two types of monochromators. Okay, filters, monochromators. Absorption filter, interference filter. Here, prism type, grating type. Prism, grating. Filters, absorption filter, interference filter. First, we will see absorption filter. Filters are this. Here you can see the absorption filter, different color, and these are using for the visible range only. UV spectrophotometer, UV visible spectrophotometer, only visible things is there. Then you are using this type. Filters are made up of a glass coated with the pigment, a color pigment, or they made up of a dyed gelatin, dyed, not a DIED, dye, color gelatin we are using. They absorb the unwanted radiation and transmit the rest of the radiation which is required for the colorimetry. Okay, and the merits are simple, very cheaper, less accurate, no problem. Bandwidth is okay. These are here you can see the complete picture of the filter. This I have already explained in visible range. In visible spectrophotometry, that is a colorimetry. I have already explained. Okay, all these filters, these are called as a filters. Opposite filter you have to use. I have already told contra color. Just like a blouse and saree, contra colors we are using. If your sample is one color and you have to use the opposite color of the filter. And interference filter, see here, this is also very important, also known as a Parrot filter. And this consists of, here inside, this consists of calcium fluoride. That's why this F you can keep in your symbol. Interference. F is there, inter, between. F. Calcium fluoride, magnesium fluoride, silicon oxide. F is the key point here. Okay. Thickness is the range, and mechanism is constructive interference followed by this equation. They're not much important. Okay. Diagram is important. The diagram I am elaborated here. This is the space. One plate here. This is called as semi-transparent silver films. Very important. Semi-transparent. It doesn't transmit all. It transmit only the few rays. That's why it is called a semi-transparent. Now, this between these two plates or two silver films, we are filling with the magnesium fluoride, calcium fluoride, silicon oxide. Very important bit. Number of times it was appeared in the examination. GPAT competitive examination. It was appeared. Okay. F is the key point here. Fluoride, magnesium, calcium. Okay. Angle space here we can see when the light will falls on here, that is polychromatic. You will get a number of range like a 200, 201, 203, 204, 205, 206 up to 400, like that it will be separate you will get. These are called as interferon filters. Now you come to the prisms. Very simple topic. These prisms here you can see the photograph, glass prism. Glass prism, how white light is converted into WebGR, like that. It's separate. Which color you want, you can use the slit here. Okay, you can use the absorption filter also or prism also. Whatever you want, you can be used in your instrument. Keep in your mind. You are not using both absorption as well as. See how the glass prism separates the visible range. In the same fashion, quartz prism, quartz means gold, which is made up of a gold. Keep in your mind, quartz prism, it separates the UV rays. See here, UV rays. Here, white light. This is a quartz prism. This is a glass prism. Here you can see this is a quartz prism. How it separates the UV rays? UV rays, no color, no color, no color, no color. Visible only color with GR. Okay, like a rainbow colors. This is the quartz. Don't write this in the examination. Okay, it is a quartz. Quartz used to make the gold. Keep in your mind the gold bearing the quartz specimen. You can see the here quartz. This is an entire quartz. On the surface, you can see the gold also. Okay, quartz is the father of the gold. You can say father of the gold, quartz. And prisms. There is a one more type of prism also is there. That is a litro prism. It looks like a pink diamond, like in Lord Venkateshwara and Tirumala is there, like a pink diamond. It looks like pink. Lit row, lit, small, very small prism. Since it is very small, it is widely used. Very small. It doesn't occupy the much space in the UV spectrophotometer, UV visible spectrophotometer. No, very small. Okay. Here, how the racy polychromatic light enters and highly reflecting, just like mirror, it reflects, no, in the reflecting the coating. Here, this coating is highly reflected coating. Here you can see. Okay, that we cannot see it directly here. Here you can see. So it divides, it separates the all the rays outside, right? Yeah, these are the prisms. Some of the prism in the exam they will ask as a directly Bunsen prism. Bunsen prism having a 60 degrees uh, angle, and it is made up of glass. Glass prism we know very well. It is for the visible range. Visible. So Bunsen 60 degrees glass prism for visible spectra only. In the exam they will ask in Bunsen prism where you are using IR, UV, visible, or like that they will ask in the exam. And next is Carno prism, just like a Carna. We will take no popcorn, sweet corn, like that. It is a Carno prism. It is made up of quartz. So we are using for the UV rays only. UV rays. 60 degrees is the angle here. Here you have a problem. This problem also appeared in the question paper, competitive exams. This What it is, two circularly polarized beams comes outside. This side. Circular, that's why I used this one, circular shape. Different velocity. See here, it is a one velocity, and here see how fast it came. Two circular polarized beams with two different velocities. This problem you can be overcome by the 30-30. Instead of taking 160, 230 you can take 30 plus 30 like that. Prisms you can make this 30 plus 30, same velocity you will get 30 plus 30. And litro prism, so far we saw the pink diamond silver line will be there. It is at 30 degrees only, very small in space, little in size, very compact, widely used in the intestine. Entry of the ray polychromatic and exit monochromatic at the same side. Same side, keep in your mind. And next is gratings. These gratings are nothing but plates only, glass plates. It looks like, see here, blank glass substrate. This is a glass. On that resins will be, they'll coat in the stepwise, just like a steps. Steps 1, 2, 3, 4, 5 steps is here. 1, 2, 3, 4, 5. These are the coatings with of the resin. This is a glass. This is called as a glass. It looks like a small plate. They'll put in the instrument. Instead of prism, you can use grating. You can use filters, prisms, anything you want, whatever you want, you can. All these are the monochromators. Okay. See here, how many steps are there? 1, 2, 3, 4, 5. 15,000 lines per inch. Here you can see 1 inch. Small scale, this is a Nataraj scale. Uh, these are the centimeters this side, and this side inch. 1 inch is equal to 2.5 centimeters. Okay, so 1 inch, it consists of a 15,000 lines. Just imagine within this space. That's why when you make a polychromatic light of that, since these steps acts disperse the each color. So to better you understand, here I made you. These are all the steps here. See here, this is a polychromatic light, mix of all colors. It is converted into monochromatic light on the same side. That's why it is called a reflection. Same side, reflection. Whereas here you can see transmission, other side, transmission. So when you make a fall of polychromatic light here, you will get a monochromatic on the opposite side, transmitted. Okay, on the other side you will get. Problem is they gave the greater than 1 OOD, order of diffraction. This is also appeared in old question papers for competitive examination. Stay radiation is one of the problem, eliminated by using the two gratings. If you are using a two gratings, you can eliminate the stray radiation. Spurious radiation, eliminating by using the baffles, not buffaloes, not buffalo, baffles. Spurious radiation. These are the two types of mounting. Not much deep is required. Okay, just in the examination, this is very important. Rowland mounting names are important, not the entire concept. Rowland mounting, how you are going to place the grating in the instrument. Rowland Ebert mounting. See, keep in your mind, Rowland mounting is also called as a Rowland circle. See how the circle is there. Keep it. And this diagram you can write in the exam. Ebert mounting, same side, plain grating with one concave mirror. Concave, you know what is the shape of concave? Symmetrical, both symmetrical, both entrance and exit on the same side. Here you can see the grating. See, entrance slit, fall on the grating, and again it fall on the concave mirror, and here you will get a exit. So here you will get a polychromatic light, make fall on this here. This grating splits into number of monochromatic, and here is the exit slit, exit. So here you can put wherever the wavelength, whatever you want to. See, keep in your mind, one important trick is there. E, letter E, like this. Ebert mounting, Ebert mounting. It is a E shape. Okay. One concave mirror will be there. We are using to draw, this is a concave mirror. Here, this line, and E is the shape, like E, concave mirror. Both entrance, exit are same slide. See here, this is a entrance, top line, bottom line is the exit, same side. Keep in your mind. So we will stop here, and in the next my video, I am making the UV spectroscopy instrumental part 2, second part will continue. Okay, thank you for watching.